Okay, so today we are studying 2.2b class activity. Go ahead and look at problem number 1. It says you studied this pattern in the previous lesson. Use your work from the previous lessons to answer the questions that follow. How many new blocks are added to the pattern from one stage to the next? So from your notes the other day, a lot of you guys noticed that you were adding one and another one here every time. So there was a difference of 2 each time. Now we're going to complete the table. So for stage 1, or our variable s, there were 3 blocks. And for stage 2, we had 5 blocks. And for stage 3, there were 7. Stage 4, there were 9. And finally, for stage 5, we had 11 total blocks. Okay, so we're going to take these and we're going to graph them down on the graph. So go ahead and I'm going to have to start skipping some. I'm doing this with my mouse on my keyboard, so this is going to be kind of an interesting graph. But hopefully we got enough numbers here that we can see. So right here on my X, this is the stage number, and then over here, this is T, or the number of blocks. And so I'm just going to go by 2's here, 2 and 4 and 6, and so on. Alright, so we go 0, 1, and 1, 3, and 2, 5, 3, 7, and 4, 9, 5, 11. And so those create a straight line. There's no way I'm going to be able to do that here on the computer, so just drawing the line here. And now let's look at problem E. It says, what is the simplified form of the equation that gives the number of blocks T for any stage S? So several of you guys had lots of different equations. What we want to do is to simplify them. So no matter what your equation is, if you will simplify it by distributing or combining the like terms, the simplified version of this one is T equals 2 times S plus 1. And where do we see the different pieces of this equation in the table and in the graph? Well, in the table, you guys see where we start at. We start at 1. And we see that there's a change of 2 and 1 every time. So we're going right 1, we're going up 2. So we're adding 2 blocks every one stage. And so that works through the whole table. I refer to the graph. On the table up here, so if you guys remember, we had 3, and we had 5, and we had 7, and so on. So if we look at these two numbers, then it's going to be a 2, and over here, they're changing by 1. And the next one, we're changing by 2, and the next one, we're changing by 1. And so we see that 2 over 1, the y over the x, or in this case, the t over the s. Okay, let's move on to the next part here. Part F says the pattern above is a linear pattern. Describe how a linear pattern grows. Describe what the graph of a linear pattern looks like. So I'm just going to talk through this one. A linear pattern grows by the same amount every time. So in the last example, it grew by 2 over 1, or 2 blocks every stage. And a linear pattern on a graph looks like a straight line. Okay, let's move on to number 2 here. And obviously inept at using the mouse. Okay, let's see if I can actually get it. There we go. So number 2, you studied this pattern in the previous lesson. Use your work from the previous lesson to answer the questions that follow. So this was on the second page from our class activity yesterday. How many new blocks are added to the pattern from one stage to the next? So here we have 1, and here we have 4, and here we have 7, and here we have 10, which to me looks like we're adding 3 every time. So to complete the table, there was 1 block, and then there was 4 blocks, and then there were 7 blocks, 10 blocks, and finally 13 blocks. So, show where you see the rate of change in your table. Well, if we're looking here, we are changing by 3, and we're changing by 1. And that continues down the table every time. Okay, we're going to go down and we're going to graph this. So, here's our graph. And let's just count by 2s again because I'm struggling here. We'll count by 2s on this side. Once again, we have S down here and we have T up here, the total blocks. So on this one we had 1, 1, then we had 2, 4, we had 3, 7, 4, 10, and 5, 13. Once again, you're going to want to draw in that line. I did not here. Okay, so what is the equation that gives the number of blocks T for any stage S? Now, all of you came up with different ideas. If you will simplify that equation, the simplified equation of this one will look like T equals 3S minus 2. And then we ask, is this pattern a linear pattern? So the two things we're looking for here is, does it increase by the same amount every time? That question is yes. And then the other question says, okay, if it does increase by the same, also, does it form a straight line? And the answer is yes. So that means that it is linear. Alright, we're going to skip down and look at the next page here. Alright, it says, describe what you see in each of the representations. So a geometric model. In our geometric model, we're looking for the same number of blocks. Same number of blocks added each time. Added each time. Let me say that one more time. So we're looking for the same number of blocks added each time. Okay, on a table, what we are looking for here is when we're looking from one ordered pair to the next ordered pair, such as 0, 1, 2, 5, 4, 9. So when we're looking at a table like this, this difference, this is called the first difference, but the difference between those is the same every time. And over here, it's 2, and here it's 2. So that's what we're looking for in a table. In a graph, we're looking to see if there is a constant rate of change. So it's changing by the same amount every time. And if we do that, it makes a straight line when it's graphed. So it creates a straight line. That's an okay line. Not perfectly straight, but pretty close. And then finally, in our equation, notice that in our equation, we're going to have our y equals, now we have a number right here. And that number that goes inside this circle here is going to be our rate of change. That's the constant change every time. Okay, so up here in this case, it was the 4 over 2. Which happens to be like 2. So we'd put a 2 right here in that box. So y equals 2x, and then did we start somewhere? In this graph, we started at 0, 1. So when x was 0, we started at 1. And so therefore, this would be y equals 2x plus 1. And so those are the things that we're looking for when we're looking at representations of a linear pattern. And that's all your notes. So now you guys just need to do what your teacher says.